Let's solve the next type of problem. See, here you're trying to verify a particular property. Okay, so two are there. Once you're done with the first one, you guys can go ahead and start with the next one also. Let's start from the first one. So you have AB. You have to verify that particular property, correct? Let's start with the verification. Very easy. First, we'll calculate what is AB. I mean, you can do B inverse, A inverse first. Do the RHS part in the beginning. I mean, it's entirely up to you. But then, anyway, you have to do both the cases anyway. So first, I'll do AB. So here, when we calculate, so for the first one, when we calculate AB, it's the product. Now, since the question, the two matrices are right there, you have 3 into 6, which is 18, plus 7 into 7, which is 49. Next, 3 into 8 is 24, plus 63. Then you have 12, plus 35. Then you have 16, plus 45. So, AB value 18 plus 49, this is going to become 67. Next is going to become 87. Next is going to become 47. Next, you have 16 plus 45, which is going to give you 61. Now, this is AB. Remember, we have to calculate the AB inverse of AB. So, for that, AB, first you have to calculate the adjoint of the matrix AB, correct? Now, if you know how to directly do it, you guys can go ahead and do it. Otherwise, you have to calculate the cofactor and then you have to do it. So, we'll do AB 1, 1. In the sense, I'm trying to calculate the cofactor. Cofactor of this first one is going to become 61. Then AB 1, 2 is going to become minus 47. Next, AB 2, 1 is equal to minus 87. Then finally, AB 2, 2 is equal to the last one, which is 67. So, cofactor matrix AB, I'll write it here. This is the cofactor matrix. 61 minus 47 minus 87 and 67. So, adjoint of matrix AB. So, adjoint of AB is equal to, you have to transpose the cofactor matrix, correct? So, when you transpose, this is going to become 61 minus 87 minus 47, 67. Remember, this is just the adjoint. You have to calculate the determinant of AB. Then you have to calculate what is the inverse of AB. So now let's calculate the determinant of AB. I know these are big numbers, but then probably once you do the determinant, you guys might get a very easy number. Fine. So let's calculate the determinant now. Remember, determinant of this particular matrix. All right. So I'll try to write it here itself. Determinant of AB is equal to 67 into 61 minus 47 into 87. This is going to give you minus 2. See, such a beautiful number you got. The determinant value is negative 2. Now let's calculate what is the inverse of AB. What is the inverse formula? A inverse is equal to 1 by determinant of A into adjoint of A. Correct? We have calculated both of them. AB as in determinant of AB as well as adjoint of AB. Correct? So this is basically minus 1 by 2 into adjoint of AB. That's what you're trying to calculate. 61 minus 87. Then you have minus 67 and 47. See, this is AB whole inverse. Now you have to calculate what is A inverse separately, B inverse separately, and then you have to calculate. Okay, see, this we'll call it as equation number 1. Fair enough? You have to take, okay, is equation 1 and 2 are one in the same? You just have to calculate this one. Fair enough? Let's do the next one part now. We'll calculate A inverse, B inverse separately. So for A inverse, okay, now for A inverse, I'll do one thing. I'll make one column here. which separates A inverse and B inverse, and we'll do it together. So here we are doing A inverse and here we are doing B inverse. Okay. Now for A inverse, first I'll calculate determinant of A. Determinant of A is equal to 15 minus 14, which is equal to 1. Determinant. Now directly we can write the adjoint also or cofactor, and then you can do it also. So A11 is equal to 5, A12 is equal to minus 2, and then A121 is equal to minus 7, and A22 is equal to 3. So when we take the adjoint, or first is cofactor is 5, minus 2, minus 7, and 3. That means adjoint of A is equal to, adjoint is what's transpose of this one? 5, minus 7, minus 2, and 3. Now we'll calculate what is the inverse of this one. So A inverse is equal to, see, 1 by determinant of A, which is 1 by 1. This is going to become 5, minus 7, minus 2, and 3. See, this is what we got for A inverse. Let's do the same thing for B inverse now. For B inverse, first we'll calculate determinant of B. Determinant of B, 5. So first is 6 into 9. Not 5, it's 6. 6 into 9. 9 into 6 minus 8 into 7, which is minus 2. Okay, then B11. B11 is 9. B12 minus 7. B21 minus 8. Then finally B22, which is equal to 6. Cofactor matrix is going to become 9, minus 7, minus 8, and 6. Adjoint of B. So this is going to become 9, minus 8, minus 7, and 6. Now guys, basically when you take the inverse, the same value divided by 2, correct? Now we'll have to multiply these two together and check, okay, is it going to be the same, correct? Now let's do the multiplication. First we'll calculate B inverse, then we'll calculate the multiplication part. The formula becomes B inverse 1 by determinant of B into adjoint of B, correct? And determinant of B we already know, so this is equal to 1 by minus 2 into 9 minus 8 minus 7, 6. Okay, so this is B inverse. So this basically is B inverse. Now what do we have to do? We have to calculate what is the value of A inverse. We are done. B inverse. We are done. Now we have to calculate. So to be calculated. So to be calculated is B inverse into A inverse. Let's just do that. We will see what is the equation 1 value. Check whether both of them are equal or not. Now B inverse into A inverse. This we have to calculate. Now B inverse minus 1 by 2 into 9 minus 8 minus 7 and 6. Next you have A inverse 5 minus 7 minus 2, 3. Now we have the normal matrix multiplication. So you take the row, you take the column, do the math. Very, very easy. Suppose once you do this one, see, minus 1 by 2 into 9 into 5, 45, minus and minus, so plus 16 is the first case. 9 into minus 7, minus 63, minus 24, minus 8 into 3, minus 35, minus 12. Then you have 49 plus 18. So minus 1 by 2, let's keep the minus 1 by 2 as it is. This is going to give you 61. Then minus 63 minus 24, which is minus 87. Then this is going to give you minus 47. Then 49 plus 18 is going to give you 67. So you got this as the second equation, correct? You look at equation 1 and so this, if you call this as equation 2, if you call this as equation 2, if you look at 1 and 2, both are one and the same. So hence you prove this one. Now this type of problem generally comes for 5 marks in your exam. Okay, proving that verification type of problems. Fine. Now this is one type of problem which is quite very important. So please go through this video again and again to understand how to solve these kind of problems.